Oh, hey guys, welcome back. I'm going to be explaining how the unit circle works and what it is, but since I'm so extra, I'm going to be making the unit circle out of a cookie. So sit back, relax, don't get hungry, and enjoy this edible pie making extravaganza. So first let's start with this base. Yes, I'm using cookie mix. Please don't judge me. Web doesn't give me enough time to make cookies from scratch. I would if I could. Anyway, I'm going to start off talking about the unit circle. What is it? The unit circle is essentially a circle centered at the origin 0, 0, or where the x-coordinate and the y-coordinates meet, with a radius of 1. That means that every segment around the circle has a length of 1. Because of these elements, it can be used to calculate trig functions, angles, lengths, and coordinates. Just to give you guys an on-paper actual visual representation of a real unit circle before I get to my decorating portion, this is an example of a real unit circle and how it is used along with its coordinates. As you can see, the unit circle contains both radians and degrees. That means that the numeric value is represented both in terms of pi and in terms of the angle amount on the circle. If you look at 30 degrees, for example, you'll notice that it's also represented in pi over 6 and also the coordinate root 3 over 2, comma 1/2. This is the value in terms of cosine and sine, which I'll explain in a moment. You may be wondering where we get all these numbers and why it actually works. Well, an easy perspective for the explanation behind this is Pythagoras. As we all know, the Pythagorean theorem states that a squared plus b squared equals c squared. However, c, the longest side, will always be equal to 1 in this case because the radius of the circle is 1 all around, hence the unit circle. So our equation becomes a squared plus b squared equals 1 squared. But 1 squared is just 1, so x squared plus y squared equals 1 becomes the equation for the unit circle. In this case, in terms of coordinates, cosine is equal to x and sine is equal to y. A convenient mnemonic to remember this, I came up with this all on my own, is that cos-x sounds like Cosette from Les Mis, and sine sounds like it's saying y in it. By following the unit circle equation in terms of sine and cos, we get the equation cosine theta squared plus sine theta squared equals 1, where theta is the unknown angle on the circle. Well, would you look at that? My cookie pie is baked and done. What I'm doing here is I'm drawing the x and y axis and all of the extending lengths from the unit circle. These are going to be covered in sprinkles so that they can be easily distinguished. To sum it all up, essentially the unit circle is a way to use trigonometry and Pythagoras to find lengths, angles, radians, and degrees in terms of pi. So here I'm using bananas to represent the radians because it's really hard to use writing icing. Even if it says it's writing icing, it's difficult to write on. So I'm going to be using green icing. If you see there's 0, I'm writing all the radians on each of the bananas so you guys can see, but it kind of just looks like globs of green icing. But I really did try. So here's a real unit circle so you guys recognize it again, and I hope you guys have learned how to use this and why it works. Thank you!
The unit circle is the fundamental object in trigonometry. Basically, all of trigonometry could be understood with a good understanding of the unit circle.
I hope you guys understand the process it took to film this entire thing. I have a ladder in my kitchen. You're welcome.